Let's see if this booger is muted. It is not. We gonna handle that mess now. There we go. Click this. Sweet. Can I click the video? Now, I have yet to figure this completely out. No, come on, man. Give me a break. So, what we're going to be working on is some RG400 right now, at least initially to start with. And then after, we're going to be working on something different. Let's figure out what the heck's happening with this thing. I'm trying to get to where I can see you guys' comments on Facebook and on YouTube. Now, at some point in time, we will figure this TikTok thing out, but I'm just not there yet, guys. That's just not happening. Not at the moment. I'm able to do like certain videos and stuff, pictures. It's fine. I'll do the short ones. As far as connecting it with my current live profile, it's a lot. It's a big ask, to be honest. So, what we're gonna do is go ahead and start working with this. I worked out a measurement earlier and figured this out. So when this booger seats all the way inside this connection, goes all the way down here. I did some measurements with it. Not too far, that's fine. All the way to the bottom. There we go. There is my measurement from there. So what I do is let's just go ahead and take a caliper and use that for our tool. Figure this out. Now that we have a caliper, we'll just take the end of this and just measure it with this tool. It's around 13 mil, should be fine. Give me a little bit of room to make sure this is done right. So this is how long I want the shield to be cut. Let me go. Excuse me. Sorry, I was a little distracted with what I was doing. This is how far I want the shield cut back. But then what I want to do is I want to measure the body. So the way I'll measure the body is I'll move that all the way back to this scour point right here and line it up right here. So now I want to cut through everything to do with just the shield portion right there. Something like this. It doesn't have to be perfect. It can be a little more than this. I'm going to zoom out or back up the camera and then zoom back in because you guys are all up in my elbow space. So we will back up and then we'll zoom back in. Oof. I don't get claustrophobic very often, but man, that got me a little antsy there. All right. So I'm going to try to stay to the right here. I'm looking at the camera, trying to make sure I keep up. Morning, waving at him, man. It's technically evening for me for sure, but definitely not on the best of schedules at the moment. We're working on some quick disconnect ends so you guys can see. We can take an end on RG400 right here and screw a connector right onto it. This has got a Teflon connector on here with a nice solid piece right here. That's how she works right there. So of course you want to tighten this up. So ideally, whenever you're working with this, what you'll do is you'll run this ring back. You'll take pliers here, pliers there, and lock that into place once your connector is on. But in the meantime, while you're routing it through whatever locations you want to route it through, you can take that end, feed it through, and do whatever you need to do to go. So pretty neat little option. I've had several customers asked me for this. One customer had already ordered it, and then I actually built it for them. A customer was asking for questions about a week before that, but had not ordered. and I kind of retroactively told them that I'm able to do it. And they ordered also. So this is what I'm working on. I'm finishing these up as a pair just because it doesn't take very long to do, but also because I want to show you guys, kind of showcase something new. It's pretty cool. I like it. Um, so I don't think it's too big of a strain on my time schedule or effort because one of these is due now and the other is due not in the not too distant future. So me working on it now is not really a big deal. Now, right after this, I've got two other harnesses that I'm going to be working on, and then I got a big harness that I'm going to be working. Big harness is coming up after those. I will kind of update you guys as I get into it. Also got some bird mirrors that I've got to ship out. Uh, two bird meters are going out the door, two dummy slugs, and I don't remember what else at the moment. All right. So from here, there is obviously a very small amount, but nothing crazy, of power handling that you do lose in this style connector. I won't say very small amount, but in comparison to what people expect to use this wire for, you're limited to about 1,000 watts peak, with this type of connector. Could you go higher than that? Maybe. I don't know how much higher. I've never tested it, so I guess you could be your own guinea pig and give it a shot. But yeah, do it at your own risk. I'm not. I'm not condoning it. I'll tell you that much. So, so what I found in doing this, there we go. Let me zoom in a little bit so you got to see what I'm doing. I don't know why I just did that kind of zoom in. Let me back off again. Back off and then zoom in that way. There. Good enough. You guys can see, I think. My late night shenanigans. We're working, like I said, on some RG400 at the moment. I will be uh, working on some other stuff after this. Now, from here, I don't know if I'm still in the shot or not. It looks like I pretty well am. You can see what I'm doing to this shield. This is a double shielded wire, so it makes the crimp a little bit more difficult the way this is set up. So what I did earlier, it's going to look a little crazy to you guys, but I'm not really trying to impress anybody. So what I'm doing, pull this back right here. There we go. So I don't really want to damage my. This is, oh, there it is. I don't really want to damage my map. So, I'm just kind of moving this out of the way. And you guys will see the crazy thing I'm about to do. You ready? It's absolutely nuts. Ta-da! So crazy. Oh, dude. We'll just slide my sleeve down, my cramp sleeve down. Now, uh, I used a piece of heat shrink earlier. Zoom out real quick. Oh, I didn't show you guys. I'm sorry. I should have zoomed out. My bad. Sorry, guys. It's the only bad thing about zooming in sometimes. You zoom in just a little bit too close, and then people can't see what you're doing. So that was not my intention. I apologize, but whatever. It's late. Next, all I did was took the pair of pliers, took a hammer, and literally slid the sleeve over this double shielded jacket. From here, the next step is going to be a little bit counterintuitive. I'm going to go ahead and grab the heat shrink right here, what I want to use, set it back. Cha. I need a bigger piece, like a bigger needle nose. I've got an in between needle nose, but it's got a sharp edge and it's designed to ream out uh, pipes and stuff. So unfortunately, when it comes to doing work like this, it's not really long enough to do what it needs to do. And this one isn't. And the other one is too sharp on the edges. You need a rounded edge, pair of needle nose rather than a sharp edge pair of needle nose. Because the sharp edge is all it's gonna do is as you string, just rip it. It's quite unfortunate. It's kind of the name of the game sometimes. Let's see. Slides. Look. And there we go. All right, that part's done. Now, next part's coming up. I'm not doing that yet. I'm sorry. Give me a second. I have, what is this? Oh, sorry. Yeah, it's positive this won't do what I need it to do, but I want to check it out anyway. Or at least I feel like I'm positive. Yeah, no, that won't do what I need. This will. All right. Gets our initial connection done. You can't do this with normal wire, so don't look at me and be like, uh, can I do this with my RG8X? No, you cannot. It won't work. Please don't copy this. It is a bad idea. Well, you gotta be careful. It didn't get me or nothing, but always something you gotta watch out for. Throw that up the way. Oh, my poor little fuzzy. All right, so back to what I'm doing. There we go. That's what I was looking for. This is my favorite cutter, man. All right, I threw my torch down, and this is like highly flammable. Like you touch it for a second, and it starts to light up. So it's very expensive. It's just got a sleeve on top of it, but these are like some crazy expensive dikes. They've served me well. I've had them for several years. I mean, this is kind of dumb using like a $90 pair of needle nose to do these jobs. You can do this with cheap needle nose. Don't feel like you need the expensive ones. It's not necessary. All right, there we go. This one is done. So now slide this over top of here. Of course, this connection's still going to be hot, so you got to be careful. wave it a hand, Mr. Hang on a second. 178, right? 178 high voltage. Make sure I got it right. Hope you're doing well, Kenneth. Now, this end is now on here. It works as a UHF end, just like this side does. But again, like I showed you guys earlier, you can do it without doing that. But I just like to showcase it. It is removable. So you poke it through whatever small hole you got to work with as far as in your cab or your vehicle or whatever structure you're working with, something like that. Look, it literally fits through a 3/8 hole with room to spare. So that's pretty sweet. That kind of hole in your truck instead of that kind of hole, something that large. So yeah, there's a difference there. Some guys really appreciate that, but that's something I was happy to accommodate. So again, for anybody who does this, if you mess up and this connection's loose and it's wiggling like this, you got good reading, bad reading, good reading, bad reading. You need to have it tight. And then what I recommend to do is if it was mine, take a pair of pliers right here, take a pair of pliers right there, tighten it up. Nothing crazy, don't Hercules it. Maybe quarter turn, nothing, just enough to snug it down where you can't get it off by hand. Lock that booger down. Don't wrench it down, just lock it in place. If I can get it off by hand, it's not on there tight enough. And that connection will work very well. Not as good as this side right here, but good for up to 1,000 watts with no real trouble. There we go. Both these are good to go, going to 2 different customers. We got some RG400 complete. That is done. To finish out this video, which is not going to be a super long video today, I'm going to do 2 more connectors for you guys. And that's going to be 1 1/2-inch flex and 1 1/2-inch hardline. If you guys would have a preference on which one would you like to see, then please speak now or forever hold your peace. If you, I don't care. I don't mind showing you guys either one because I've got to do both of them. Don't change what I got to do. So comment now, then your vote will be counted. If you do not have not commented on here before, I don't think you realize how much weight your comment has. It's not. I don't know what it is about you guys, but there's a bunch of guys that come in here, but they don't. A lot of them don't comment. And if you don't comment, then your vote don't count because I don't know what it is. So there's a bunch of guys out here that'll watch this stuff, but only a couple will comment. And when they comment, I usually will follow what they're wanting to do. So that's 1/2-inch hardline, and that's 1/2-inch flex. I'm going to zoom out real quick, and I'm going to go grab the connectors that I need, and you guys tell me which one you want me to work on. I see 1 vote for 1/2-inch flex, and we'll go forward from here. That's should be good. All right. Now I am grabbing. I need to get this one over here. I might have to restock these connectors. I feel like I might have to, but I think no, they're just all out of it. No, I don't really know. I think I figured out they're in a shorter package or something. All right, so I'm coming back looking for votes. So whatever you guys say is what we're gonna be doing. Here's one connector for the 1/2-inch hardline right here. Gonna be this one right here, and the connector for the 1/2-inch flex. Look at my stuff. Is gonna be grabbing this connector right over here. Where is it at? Which one am I using? Yeah. It's that one. Then uh, that's this one, but that's not the one I'm doing. Check what's this dude's name. There we go. So now this one's gonna get, I wrote it down. Okay, I already know what we're doing here too. Now this one's gonna have these right here, and I'll grab two of them just so I have them. Let's go on to the next. All right, what's the vote say? Let's tally them in. If we got one vote for, we have one vote for half-inch flex. I can't believe you, YouTube. You guys let me down. All right, let me zoom out just a little bit. We're going for half-inch flex. One vote is the one that decided what we're doing. So we're doing some half-inch flex, and we'll get that done. I got to do. Let me grab another one. Gave you guys a chance. Have your own voice, and you didn't. All right. Am I missing one piece? No, that's this is for this. Yeah, I guess so. Let me grab one more. Well, no, I'm not. I'm just gonna do this because now half-inch flex is this wire right here. So we're gonna throw this other harness down, and we'll go ahead and grab half-inch flex and throw an end on it. Can't believe you guys on YouTube. You guys let Facebook decide what you guys are doing. All right, let's zoom in. Here we go. Here. Yeah. I don't know what it is about late nights, sometimes high voltage, but sometimes I second guess myself. Like I do my best to try to remember handles and names, uh, but sometimes it's difficult. So this is the connector we're going to be using. Um, I've done enough of these. I'm just going to go ahead and get to work on it, and then we'll go ahead and do the next one right after. But feel free to watch while we're working. This, yeah. Mm, good, but it'll look good in a moment. Let's see how this lines up. So, we'll wait with these out there. Cool. First thing we're going to do is go ahead and prep this material. I think we're zoomed in. Nah, we're zoomed in. Zoom in a little bit more. Pull the camera down. Turn it over here. I think that'll be a pretty good spot for you. Throw my trash away. So I'll use the caliper for this part. Let's put it in. First mark. What was it? Um, sure. Let me show you guys real quick some old school paper. So I have a few of these. When you look right here, let me get it open real quick. This gives you options to use hand tools. It gives you options to use the drill tool and a bunch of other parts and components. It also tells you certain methods for how you tighten. You want to hold the back still. You want to turn the front. So keep stuff like that in mind. You definitely need to do a little bit of learning. If you don't know how to do like some of these custom connectors, then definitely you want to make sure that you understand all of it before you start kind of going rogue on what I was doing earlier, doing all your own custom stuff. How many watts can you go through half inch? Half inch can go about 7,000 average. At anything in the lower HF spectrum. Anything in the higher spectrum, of course, there's uh, different power limits to that. Depends on what frequency you want, but from anything, like I said, HF and below, uh, you're good for 7,000 plus. All right, so we're prepping that material right there. This is acting like our seal right here. It's kind of like an O-ring, but it's a little different. It's a helical pattern. Now we'll use, I used, what did I use? Let's try something new. Let's try this. I like to expand my, no, not wide enough. Man, I wish this was wider. I think this thing's starting to get kind of dull on me, so we'll see if I regret it in just a moment. All right. First, mostly good, but there's a little bit of material right here. All right. Well, there's a little bit of material on the back side I'm positive about, but I'll pull it off real quick. When I pull this off, you'll see what's happened on the back side a little bit, like that. Just a little bit of excess material. Sharp her off. And then a little extra piece I missed. How did I miss that? All right. Go ahead and cut our jacket back this far right here, and then we'll tidy up in just a second. And that's half-inch flex. No, there's half-inch hardline that can handle more. It'll do about 8,000 average. That is 24/7 use, 365 days a year. That can be used in commercial broadcast or pretty much any. Now, of course, again, frequency dependent, but anything below 30 megahertz, this number is pretty relevant. Uh, Technically, the higher part of 30 is not considered. But yeah, I mean, I could argue that even at the higher part of 30, it drops a little bit, but not much below that. What is like the shortwave? 26.8 or whatever, from 26.8 all the way up, all the way down to like 400 hertz or some crap. It's this would be correct. I think that's what that shortwave one had for frequency range. So what I have to do from here is make sure that the helical pattern, the spiral helix that I got on here, has not been modified in any major way, and that when it starts, there's nothing to get in the way of it. So that's what it's doing there, cleaning up that little edge right there. Now, just pulling this down to get past all the rest of this material right here. Start our threading process like that. Here, put this material down on here, and we'll continue forward. So let's go ahead and get some tools. I have them on the top of this toolbox right here. I am not liking the look of this. What are they doing? I've had a bunch of these. Let's see. Let me check this one out. I got to do this here in just a minute anyway. No, that's fine. It just looks weird. this is going to bottom all the way out. There we go. There. I'm just doing it by hand just to see how this lines up. All right. Okay. Just testing the edge. 7 now. Smidge further. Now, and dead on what I need. There we go. You guys got questions? Feel free to ask. I'm doing, like I said, 7/16 DIN connector on some 1/2-inch flex. I've done enough of these where I can answer questions while I'm working, so don't feel like you're bothering me, because you're not. If anything, you're keeping me entertained, asking me questions. So we're deburring right here. And now, put this on. Grab another piece real quick. This has got a so the goal is, once you put this on, try to rip it off. If you can rip it off, you didn't do a good job. So wasn't able to pull it off, so it is connected and working properly from here. So this one's all done and finished up. I'll show you guys how the other ones work a little bit later. So that one's where we need it to be. I'll go ahead and grab our handy dandy fancy heat shrink and shrink this down. Oh man, how did I get out of the shot with a heat shrink? My bad. This is a UH 7/16 DIN connector is what this is. This is your next size up from your PL259. It, along with the N connector and several other connectors like it, are known as like a true impedance cable, a 50 ohm cable, 50 ohm termination. A UHF connector is technically a 52 ohm connector. It works quite well for what it is, but it's not quite as precise as some of these other connectors. But yeah, There she goes. Den is on and in place. We'll go ahead and do the 1/2 inch hard line. And then I think that will be a pretty good end for this evening. I've got plenty more I've got to get done. I've got to get some more things shipped out. I'll be working on shipping some of these packages after this video. Obviously, I don't really video that just because it's not much to video. It's just shipping packages. So it's not video worthy, we'll call it. So let's go ahead and move the camera a little bit. I think just out just a little bit because when I'm working with 1/2 inch, I have to move it a lot more than I do 1/2 inch flex. So that's funny. Ain't reason why. Now, our goal here is to hit on a high part on the flange. So what I'm going to do is I'm going to take this right here and see if I can get away with it. I've done it before. I'm not sure I can get away with it on 1/2 inch. I know I can on 7/8 just fine. 1/2 inch is a little bit less forgiving. So let's see if I can do it. So high edge is here. Mark it right. A little bit below that high. Okay. Oh, I need to. Edge. Now, I want to inspect what I've done, but I don't want to say cut the jacket where the wire gets weak, uh, and not have an opportunity to try for another recut. This is going to be successful. I guess I didn't really make an announcement to say whether that was going to work or not, but it's absolutely going to work. But what I'm doing right here is just pulling this jacket and I'm kind of doing like a reverse analysis. So when I made my cut, I cut it right here. So this allows me to see what material I've got, what kind of flange I've got to work with, and if this is going to be a good cut. And all in all, it's going to be a pretty great cut. So I'm going to use that and let's go ahead and get to work. I'm not using this because that is a DIN connector for 1/2 inch flex. So we're going to go ahead and cut that back there. Throw that material over there. That will be a Thursday project. We'll finish up. And then, of course, we'll put the same hard line that same day. Now, I've got to go ahead and kind of see what I need to do from here. I've got, I got some paperwork right here. I might as well just show you guys. This is the wrong one. I'm literally digging the stuff out the trash just because I can. It's right here. Yeah, there it is. Because I was just working on 1/2 inch hardline the other day. So, according to the manufacturer, they want you to. This is what I wanted to explain to some of you guys before. They want you to cut beyond what needs to be cut and then remove the actual end and cut it shorter afterward. Me personally, I do not want to do that. That's nothing I prefer to do. So I cut to where my flange is proper, and then I cut to the measurements they call for after. In this case, it'd be 33 mil, and then about 7 mil on the other. So I'll take my handy dandy caliper right here, zero that mover out, go out to the measurements that I need. Down there, mark it right there, see if it hits a good spot, and then measure my initial measurement right here. I didn't mean to do that, but it doesn't matter. You don't need to see the number. It's just 7 mil. What I picked. So I'm gonna shoot for the same tactic, but I'm gonna do it a little bit differently. So I want to see if I can get away with this. Here is the attempt. this is a sharp edge right here. Uh, Typically, you would do this with like a hacksaw or something. I'm trying to avoid that aspect, just simply because kind of defeats the purpose of what I'm doing. I'm gonna try not to cut too deep this connection, but I want to try to get this. Make sure I'm not again cutting too deep. Mm, Not quite deep enough. All right. Let's see if I can get this off from here. If I can't, then I will not have cut it properly. If I didn't cut it properly, then just got to deal with that in a minute. Yeah. Let's just be a little bit more aggressive with it. Might as well. So what I'm trying to skip is a whole step in the process of working on this, and that is the step that is shavings. When you're working with stuff like this, you have to deal with a major amount of shavings. So the goal is, if I can avoid it, to ideally not have to deal with those. Let's see if I was too aggressive in my maneuver. Right here, very, very little to deal with, luckily. So I'm just going to clean out those shavings before I have to deal with anything in the future. Now, I did make a mistake in my initial measurement. So typically when I'm working on like my EIAs, like these connections right here, this is an EIA flange. And then I've got a smaller EIA over here somewhere, probably back here. Yeah, here's a smaller EIA right here for like your 7/8. Typically those are a flush cut mount. So I was paying attention to how I was going to be in a flush cut scenario, but I needed to know where I was going to be in a 7 mil scenario. So here is a moment of truth for that. So I'm doing another cut. Where I'm at on the flange, I'm still not unhappy with. Let me see if that's the cut that I wanted. That's the one that's a little rough. Yeah, that should be fine. No problems with that. So overall, still happy. So now I need to see where this sits. This needs to be sitting right here on this lower part of this hole. So I need to go just a smidge lower with this cut. Now what I have done on a few of the larger wires is I'll take this jacket and I'll go around it with like, say, a pipe cutter or something, just to mark my lines for my cut. But I can jerk my hand around this one enough that I can pretty well say say that I can cut this straight. Now watch this one be the one that's the exception, and it's not straight because I was cocky and said I could. I don't know. We'll see in a moment. So, trying not to be too aggressive with the jacket. You got to be careful when you're working with stuff like this. You got to not cut into the shield itself, because if you do, then you kind of just have to start over. There's not a, there's no fixing that once you break the shield. I mean, I guess you could probably put a little bit of solder on it or something like that, but I'm so early in this process, I would absolutely just start over. So now we're going to go ahead and grab my container, shot of my end. I will not be using this piece again. Now, please. Now, if YouTube would like to, under any circumstance, if you felt like it, feel free to comment in there. Don't hurt my feelings none, and I can try to answer you guys' questions. Most guys are asking me, "What the heck are you working on?" Because they don't know what the heck I'm doing. This is a fairly niche thing, so definitely, I don't mind your questions. So don't. It's not like I'm gonna sit there and criticize you because you don't know what I'm doing. This is more of an educational page and less of a watch what I'm doing and shut up page. So just so you guys know. Da, 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 da. Okay, it's loading. We're gonna go ahead and prep that. One of these days, I'll get YouTube to talking. I definitely, I'll get some guys in there. They'll hop in and they'll start talking and they'll say some stuff and things like that. But it's definitely usually a small margin of them. Facebook, you guys are cool. You guys, of course, will hop in there a lot. But YouTube's still learning because YouTube's early on. I think everybody falls into the mentality of either one, enjoying the video the way it is and they don't care. They don't need to ask a bunch of questions. Or two, they feel like they're going to get criticized in something. And I hope the answer's never going to be no, never going to be two, but I can only tell you guys to ask whatever you like is meant so many times. After that, I'm just going to get my butt to work and want to rebuild this flange right here that I'm doing right here. So what I'm doing next is I'm flaring this connection out. So if you'd like was to consider it like a gas line, gas pipe or something like that, I'm flaring that connection out. So as soon as I can get it flared out, I have to also take the dielectric, which is a foam polyethylene, and I have to take that and separate it from the inside of the shield so I can make a good uh, clamped on connection with this type of end. So it's pretty important to get this part right. So I'm taking my time a little bit. I'm just taking that jacket and I'm just kind of tucking it in, getting it out of the way so that I can build a proper flange on this. Because if I start building the flange before I get the jacket out of the way, then what happens is the flange will get jammed into the dielectric will get jammed into the shield and it'll block our connection that we're trying to make here. Uh, so we got this flared out pretty good, pretty good place. I'm pretty happy with how much is out of the way. I'm also happy with the amount of material that I see in here. I'm looking for copper shavings or anything inside my flange. And if there's nothing in there, I am happy. Currently, I'm happy. I also want to deburr the shield, or excuse me, the center conductor. Any sharp edges that may be on here, I want to go ahead and knock them off. And what this allows me to do is to make sure that my connectors, if I can build them properly, which is what I'm trying to do, will never fail. Dielectric breakdown can cause premature failure on a coax, and a lot of that stuff is in construction. Just FYI. All right. Put this down here. This lines up. There we go. Now, once that connection's on there, you're supposed to lock that connection down. This connection is different. This can move. It's opposite of what the flex is. So instead of focusing on the connector on the main body and rotating it, I'm now isolating and keeping it from movement in the center contact and the rotation around the shield or the body. I'm locking that part down. So the goal here is to, again, try to pull this off. If you've made a mistake, when you go to pull it off, it'll just rip right off because the flange won't be built well enough and it'll just pop right off the connector. So that's how that works. We are done with a 1/2 inch hardline. We are done with a 1/2 inch flex. We finished our quick disconnect RG400 connectors. And that is it for the evening. It is a late night start and didn't get a bunch of stuff done. But if you guys need anything, just let me know. I have a website over here. I just knocked over all my cards, but it'll be all right. It's dwinsrfsupply.com. Appreciate you guys. Y'all have a good one. And I will catch you guys later. See y'all.